Welcome back again to the new learning video. Today, we're going to dive headfirst into the world of AWS networking. Seriously, if you've ever wondered how all your services in the cloud actually talk to each other and, to the rest of the internet, you are in exactly the right place. We're going to break down how you build your own virtual data center, starting with the most foundational piece of the puzzle.
So let's start with the absolute foundation of any environment you build in AWS, the Virtual Private Cloud, or VPC. The easiest way to think about this is that AWS gives you this massive global cloud infrastructure, right? And a VPC is your own private, totally isolated slice of that pie.
And inside this private slice, you are the boss. You have complete control. You get to define your own IP address range, you create your own subnets, you configure all the route tables and network gateways. It's kind of like having your very own traditional data center, but without any of the headaches of managing actual hardware.
Yeah, a really great analogy is to think of your VPC as your own private plot of land that you've claimed within the huge territory of AWS. So you've got your space staked out, but now you've got to decide how to partition it and what you're going to build on it.
And that, right there, is where subnets come into play. Think of subnets as the different zones, or maybe even the individual buildings that you're going to construct on your plot of land. They let you partition your VPC so you can organize and, more importantly, isolate your different resources from each other. Now, you've got two main flavors of subnets you can create. First, there are public subnets. These are connected to the internet, which makes them perfect for things like your web servers that need to be publicly accessible. Then, you've got private subnets, which are completely shielded from the internet. This makes them the perfect secure home for your databases and backend services. Okay, so we've got our land, the VPC. We've got our buildings, the subnets. Now it's time to actually place our resources inside them. And in the AWS world, a super common resource is a virtual server, which we call an EC2 instance.
So here's how it works. When you launch an EC2 instance, you choose which subnet it's going to live in. As soon as it spins up, it gets a private IP address. This is the address it uses to talk to all the other resources inside your VPC. Now, if that instance happens to be in a public subnet, you can also give it a public IP address, so it can talk directly with the wider internet. So we've got these internal and external IP addresses, but how does the traffic actually get in and out of our VPC? I mean, just having a public IP address isn't quite enough. You need a gateway. You need a door to the internet.
And that door? Well, that's called an Internet Gateway, or IGW for short. You just attach one of these to your VPC, and it acts as the main entrance and exit for any and all internet traffic coming from your public subnets. The best part? It's highly available and it scales automatically, so you never have to worry about it becoming a bottleneck. Okay, but this brings up a really important question. If our databases and backend services are tucked away safely in a private subnet with no direct route to the internet, how in the world do they do things like download critical security patches or call out to third-party APIs? I mean, they're supposed to be isolated, right?
The solution is pretty clever, actually. It's called a Network Address Translation, or NAT instance. This is a special resource you put in your public subnet, and it acts as a secure middleman. Your private instances send their outbound traffic to this NAT instance, and then the NAT instance safely forwards it out through the Internet Gateway.
What the NAT instance does is create this secure, one-way door. It lets your private resources talk out to the internet, but it prevents the internet from ever starting a conversation back in. So, now that we have all the basic plumbing and connectivity set up, let's talk about the final layer, the security firewalls.
In AWS, you get two main layers of firewall protection. First up, you have security groups, which are kind of like a personal bodyguard for each individual EC2 instance. Then, you've got network access control lists, or ACLs, which are more like a security checkpoint at the border of an entire subnet. Let's quickly break down the crucial differences here. Like we said, security groups work at the instance level. Network ACLs work at the subnet level. Another key difference is the rules. Security groups only have allow rules. Anything you don't explicitly allow is just denied by default. Network ACLs, on the other hand, let you create both allow and deny rules, which gives you much more granular control.
But honestly, maybe the most important distinction is state. Security groups are stateful. What that means is if you allow a request to come in, the return traffic for that request is automatically allowed back out because the firewall actually remembers the connection. Network ACLs are stateless. They don't remember a thing. So if you allow traffic to come in on a certain port, you also have to create a separate explicit rule to allow the response traffic to go back out.
So here's the crucial point, the big takeaway. All these things, VPCs, subnets, gateways, firewalls, they're not just a random list of features. They are the fundamental building blocks. And really understanding how they all fit together is the absolute key to designing architectures that aren't just functional, but are also secure, scalable, and resilient in the cloud.
So we've laid out all the fundamental building blocks for you. Now I'm going to leave you with a final question to chew on. Using these components we just talked about, how would you go about architecting a classic, secure, 3-tier web application? Thank you so much for watching the video. If this was helpful, we'd love to hear your thoughts on that architecture question in the comment box below. And hey, don't forget to subscribe for more explainers just like this one. We'll see you in the next one.